Do you need more estuaries in your life?
I do.
Everyone does. So tune into this episode and find out some cool estuary facts.
We get some rum and beer, expensive, put in a reindeer, so you know we're gonna party.
Hello everyone, and welcome to the latest episode of the Marine Conservation Happy Hour podcast. I'm one of your hosts, Dr. Craken MacCraic, and I'm joined by Dr. Scarlett Smash. How are you doing, Smashy?
Hi, I'm doing great. What do you do when you go to an estuary? I feel like you go hunting for weird little hidden species in the mud and stuff like that.
Oh, yeah.
Right? So hold on. So that's what I did, Dr. Kraken. I scoured the internet looking for an expert in estuaries. And guess what? I got one. And for 16 years, Byron Toothman has been working in estuaries. So I'm like, oh my God, I'm so excited about this.
Now, I grew up very close to an estuary.
Did you?
In the Severn Estuary. So people from the UK might know Western Supermare or Western Supermud, as we would call it, and Minehead and places like that. So a really big, economically important estuary for centuries and centuries and centuries. So I've always had a soft spot for estuaries, and most of that soft spot being huge amounts of mud.
Yeah. You know what's also really great about estuaries is a lot of people are not around. You know, like if you go to the beach or something like that, there's a ton of people. And it's kind of annoying and you kind of want to connect to nature and it's not quiet and you just got screaming kids and all this other stuff. But estuaries are always like peaceful and calm. And that's why I've always liked them.
All the bird life and all the
okay, well, enough
species.
about that.
Anyway.
Brian, welcome to the show. Please introduce yourself.
Hi. So that was a nice introduction. I'm Byron Toothman. I work at the North Carolina affiliate of the National Estuarine Research Reserve System. And I've been here for almost 17 years now, working in the same place. I'm part of a group that heads up all of the environmental monitoring in this area. We collect water quality and weather data and mostly just make it available to the scientific community, to researchers and educators, and we try to do a little bit of synthesis and encourage synthesis of the data and make it available to decision makers and folks that need to have that sort of thing in hand.
I love the fact that you said you treat the reserve like living laboratories. Can you please expand on that?
Yes. Well, so, a lot of people like to live close to the ocean. Most of our big population centers are in close proximity to the coastline. And so the interface between civilization and the water is becoming increasingly heavily built on. And so it's difficult to find places, if you're in the business of research, it's difficult to find places that can be sort of a control. So you want to compare something that's relatively undisturbed. I mean, everything's been disturbed to some extent, but we try to maintain these areas in as pristine a fashion as possible, so that if you do want to conduct some research, we can provide this place for you to sort of like make a comparison between what's here and what's over where it's more heavily built, as an example. There's lots of other reasons to do your work here, but yeah, so that's why we keep it referred to as a living laboratory, because it's a great place to do a lot of your research relatively undisturbed.
There's a huge number of marine labs that are based around estuaries, of course. I mean, that's why. Great place to do research.
Mm-hmm. Now, for your monitoring program, could you kind of walk us through that and what you're looking at?
Yeah, so the NERS, the National Estuarine Research Reserve System, is it's underneath NOAA, and they have this program that we call SWAMP, SWMP, and that stands for System-Wide Monitoring Program. And so every NERS around the country, and there's I think the number right now is 30, but it's always increasing. They have a SWAMP program where they do the same style monitoring at every single place. They follow the same procedures and protocols. You use the same materials to calibrate your instruments, all of that stuff. So in the end, if you want to take data from North Carolina and then say from the Chesapeake Bay Reserve, which exists up there, and you want to compare these things together, the data is relatively clean, it matches up nicely, and you're comparing apples to apples. Everybody that's been collecting this data that's in this group has been doing it the same way now for well over 20 years in most cases. And so it makes it really easy to download. You can get online and you can download the entire system's archive of data from every reserve and every station, and it all will line up nicely.
You mean a layperson, a common person can download?
Certainly.
You know what? I am doing a project at the moment where trying to look at a trend for this endangered species, and everyone used a different method and different distances and different areas. And although we've got like 20, 30 years of data, none of it you can compare. So it's really, really frustrating. So that's really nice. You've got all these comparable data sets.
Yeah, that is a really strong point with this. And then now we're well into the era of big data, and when you start looking at environmental data, it's extremely messy. And so when you can find some source where the data is, a lot of it gets referred to as data cleaning. You're like trying to troubleshoot things that don't match up and look right and line things up so that you're comparing the same time and the same time frames. It's very difficult and tedious.
We know. I feel like Dr. Craken, when I was a graduate student, Dr. Craken had just piles and piles and piles of research that just needed to get organized for someone to write a paper. And so when you told me that everything is just structured perfectly and can be compared, I'm like drooling. I'm like, oh, I wish someone presented something like that to me.
A lot of our data in Scotland, we had boats sailing through the middle of mountains and things like that because that sort of thing. Oh, my bane of my existence. So with these data sets that you have you got any sort of preliminary findings about trends or shifts or things like that with estuaries across the country?
Yeah. There's at any given time, there's somebody within the reserve that's making a really great attempt at synthesizing the data and trying to pull out what we can, and they focus on different things. One of the nice things about this particular data is the temporal resolution. It's every 15 minutes data gets collected at every station across the reserve. So if you want to look at trends across, a daily or a tidal cycle, you can do that. We've got, that sort of thing, and you can start to tease out metabolic effects of just the sun coming up, or you can back out a little bit and you can start to see things like annually or monthly or seasonally. And then now the data set's been around for long enough that we're starting to really connect it to these larger atmospheric oceanic cycles. You can certainly see the ENSO, El Nino, La Nina. There's been some work connecting it to the Pacific Decadal Oscillation, that sort of thing. You can absolutely see climate signals in it. And just the other day, I was kind of messing around in R, and I was looking at just at our station and a couple of others, we were able to see that the average of the maximum wind gust speed over time has been increasing, which sort of makes sense when you think that, we're adding energy and heat to the system. So the amplitude is increasing, the heat engine is ginning up. And that's one way that you can see it.
Wow.
I imagine with all that data as well, you've got so much that you can pull out really subtle effects that a lot of short-term, small area studies don't find either.
Give us an example. I'm thirsty. I feel like you're stroking my nerdiness, and I'm like, oh, lots of data.
So one example that's really near and dear to me, we have one of our stations at this place. It's basically a walled off basin from the Cape Fear River. So it's fed by Cape Fear River water that kind of percolates in through the wall and through a couple of other small tidal creeks, but it acts kind of like a bathtub or almost like an incubator. It fills up and then like drains out. There's not a lot of flow. It's also really shallow. And one of the things that my coworker and I do multiple times a year is go through the data, and we do a lot of QA/QC. So we go in and we're validating data. And at this one station, I kept seeing our pH in the wintertime would peak up like right around like 9.0, 9.1, sometimes sometimes higher than that. And this is water that should be buffered. It's well mixed with seawater. The salinity is right, between 20 and 30 parts per thousand. So the pH should be lower than that, like
7 point something.
Yeah, between 7, 8, 8.5, 8.6 wouldn't be out of this world. And normally when we see something like that that's so out of the ordinary, we just say, okay, we're not sure what's going on with that instrument, but clearly it's out of whack. But I had also been troubleshooting our weather data, and I noticed this pattern that when it hasn't rained for a while, then all of a sudden it rains, then I see this ratcheting up of the pH on a daily basis. And then it goes away and the pH looks normal again. It happens right after there's a big shift in wind or an increase in wind or some sort of disturbance. And what I figured out was that the water is becoming heavily stratified. And so that prevents exchange between the water and the atmosphere, gas exchange. So it would get this freshwater lens after it rained that just prevented any gas movement in and out of solution. And so all of the phytoplankton and photosynthesis that's going on was actually resulting in a raised pH. The sun would come up, it would turn on the system, the plants would start photosynthesizing, and they're drawing carbon out of the water. And that carbon gets into the water by dissolving carbon dioxide. For plants, they use dissolved inorganic carbon. So CO2 dissolves into the water, becomes carbonic acid. One way or another, the plants pull that out. And when you get rid of the acid, the pH naturally goes up. And so every day the sun would rise, they'd pull more carbonic acid out of the water. And the sun would go down and the sun would rise again, and it would get higher and higher stepwise until some sort of wind blew that stratification apart.
Very interesting.
I love that you know all that information.
That's really, really sort of nerdy and a long explanation for it. I'm sorry. Sorry it took me so long to get that out.
So it's almost like little dead zones, but instead of lack of oxygen, it's like
yes, exactly.
The acidity levels change.
Right, and very much like a hypoxia that you might see in the summertime. If there's not much of a mechanism for gas exchange, all the opposite system, respiration, is sucking all the oxygen out of the water and then respiring and putting out carbon dioxide. So you'll see the pH and the DO move in a different way during that. That's usually a warm weather effect here.
So the moral of the story is don't assume that your equipment is broken. It might actually be a scientific phenomenon. Don't assume something's broken. Actually look at what's going on. Yes.
That's the lesson.
I never thought about it like that, but that's an excellent lesson.
That is glorious. I love that. So continuing with these trends, because obviously the storms are getting much more stronger and scarier and more frequent. What are you seeing, and what is your prediction, and what are you worried about with your estuaries and the water quality?
Well, we're seeing a lot of, not so much, and I could be wrong here because this is not necessarily my wheelhouse, but the intensity of the storms is not so much the problem here as the behavior of the storm. They might be bigger and broader, and the top wind speed might not be, the thing that's most problematic in all cases. It's the duration of the wind and the area over which the wind field dispersion. And I know that we've had some like really major catastrophic storms coming in, especially down in the Gulf. But the one that hit us most recently that was catastrophic in this area was Florence. And Florence looked like it was coming in as a Category 5, very, very likely, and it stalled and became a Category 1 that just hung out over top of us for a week. Just got incredible rainfall, and this constant wind was very destructive. And it turned the city that I live in, Wilmington, into an island. You could neither get in nor out for more than a week.
So with hurricane, size isn't everything. Sometimes how long it takes is the critical thing.
Definitely another factor to consider. Yes, the storm largeness of the storm is a very big deal. And then when, in terms of the water quality, the river that feeds 2 of our stations, I said normally it was between 20 and 30 parts per thousand or so. That varies all over the place, but for almost a month, it was 5 parts per thousand or less. So you totally change the salinity of the area for an extended period of time. I'd say it didn't get back to what I would call normal for That was in September, well into December, before things looked like I thought they should.
Now, estuarine critters are kind of used to a very changing environment with tides going in and out and drying out and so forth. But, do these events still have a major impact, even on these pretty sort of environmentally resilient species?
Yeah, I would agree with what you said, within reason. Everybody has their sweet spot, that's where they want to be. And estuaries are so dynamic because it's the interface between fresh water and salt. But all of the organisms find their place, and it's usually based on something like the salinity tolerances. And there's a lot of organisms that can withstand momentary or very brief changes from, let's say, the upper salinity range down to almost fresh. I mean, blue crabs can do that fairly easily, but you start doing that for extended period of time, that's going to cause some metabolic issues.
So if you were talking to a marine biology student and they were coming in and they were thinking about what to do, what would be your sales pitch for studying estuaries?
Wait, hold on. Or what topic? My thing is that it's really easy to go into estuaries, right? But what specific topic would you suggest while you're going to estuaries? So yes, I'm going to make it a little bit harder. So go on with the elevator pitch.
Yes.
Are we assuming that I care a lot about the well-being and the future of these students?
You're being a responsible
you don't
supervisor.
Want them poor.
I'm not just looking at their tuition dollars.
Yes, exactly. You want them to be able to have a job.
Yes.
You have to acknowledge, we all have to acknowledge the vow of poverty that we take.
Oh, yes, exactly. That's why I'm saying, what is it?
So the first thing I would do is tell a student to do is take a look around, as you're selecting this field, look at what jobs are available and try to identify what seems like the hot topic now that not everybody is doing yet, but everybody's talking about. And there are two areas in particular that are just really a big focus. One is remote sensing, GIS, spatial analysis of things, and that's becoming easier with our big data methods. Data science is coming out. Actually, if I was going to tell anybody to do anything and have job security, it would be data science in the area, in the field of ecology, anywhere in science. But drilling down closer to that, where we generate the data, eDNA seems very interesting to me right now. So,
oh yeah, really, really hot now. Yeah.
And what is that?
So our methods for extracting information about the DNA that's in the environment, they're becoming much more sophisticated and comprehensive. And this is not my area of expertise, so I don't want to, get into too many details.
Well, don't worry. Anything you say, we'll believe. It's not our expertise either,
just us and a couple of 10,000 of your closest friends,
and we'll all believe it
on the podcast.
So, if you were to go out into the field and collect 50 gallons of water and then process it for all the DNA that we can find in there and try to identify the potential species and organisms that it came from, 10 years ago, you would have gotten an interesting answer. It would have given you a sense of what's around. Every year that goes by, our ability to deepen that synthesis and look at what's there in smaller and smaller amounts, it's increasing exponentially. So now you need less water and you can find so many more things. There's actually a bottleneck in information. We don't have enough people and processing power, and that's changing too. But to actually look through all of the data, I had a friend of mine say a couple of years ago that they could very easily not collect another ounce of data and spend the rest of their career processing other people's stuff that's just freely available online. Plus, it's interesting. So if that's, I think if I was going to give somebody advice, I would look for the spaces between these exploding fields and try to see if there are connections, meaningful connections that can be made between those fields.
Yeah.
Because that's where nobody's looking. And you need to be able to communicate between these areas. Like, who would have thought that really ecologists and environmentalists, they needed to know economics?
Yeah.
Yes.
Right. Yep.
Two completely different things, but if you're one of those few people that can bridge those two fields, that's the kind of stuff that's going to save the world.
Absolutely. Like conservation and human behavior is just huge at the moment.
Or policy.
Yeah.
Or
Can't really have one without the other.
Or integrated. Okay, so we're obsessed. We're obsessed with everything you have to say because I didn't even get a chance to talk about species with you, but we're running out of time. So hopefully we can intrigue you to do one more episode with us on your favorite species in estuaries.
Sure, you could do that.
Okay, fabulous. Yay, we did it, Dr. Craken. So for everyone that's listening, thank you so much, everybody, for being here. And we will have Brian back on the next episode. Hey, Marine Conservation Happy Hour crew. Don't forget to hit subscribe and follow us for future episodes. And also, refer us. We'd love it. We would also like to hear from you, so please contact us on social media or you can email us about a topic that you're interested in hearing about. If you're interested in sponsoring this podcast or you would like us to come visit your science facility and do a live episode, email us at info@absolutelysmashingllc.com. This podcast was edited and produced by Absolutely Smashing. The music is produced by Jolly Shore Leave. Thank you again for listening, and we couldn't do this without you. Thank you so much for being part of the Marine Conservation Happy Hour crew.